Hello everyone, it's graphing quiz review time. So let's first talk about the coefficients for a parabola. If you've got a parabola that opens up, then I know in standard form ax squared plus bx plus c, the a value is positive. If it opens up, the a value is positive. The other thing that's easy to look at is the y-intercept. Here the y-intercept is positive. The one that's tricky is the b value in there, and the way that I remember this, and this is probably something that you should just memorize, is when a and b have the same sign, the axis of symmetry is negative. It's on the left. Okay. When a and b have the same sign, the axis of symmetry is negative. So that means the parabola will shift to the left. The axis of symmetry will be over here. So in this problem, since it's off to the right, the axis of symmetry is positive. That means that a and b have to have opposite signs. If a is positive, then b has to be the opposite of that negative. If a and b are the same, it goes left. If a and b are opposites, it goes right. But you can't just look at one thing. You have to know a for this to work. So since this one's on the right side, the axis of symmetry is positive, a and b are opposites. The vertex is at the bottom. We call that a minimum. So if it opens up, it will always be a minimum. And the last thing, the number of real solutions, number of x-intercepts, there are no x-intercepts in this problem. All right, so we're going to kind of do a couple of these first. Here, it opens down, so a must be negative. B, since it opens down and it's on the left, a and b have to be the same. A and b are the same. So if a is negative, b is negative. And that's what I'm saying is, depending on the sign of a, you can't just look at b. Since this one's negative, they're the same. The y-intercept is also negative, and the vertex is at the top, so that makes it a maximum. Real solutions, 1, 2, 2 real solutions. One more. This thing opens up, so a is positive. B, since it's on the right, a and b have to be opposite. So if a is positive, b is negative. C is the y-intercept. The y-intercept is positive. The vertex is on the bottom, so it's a minimum. And the number of real solutions, it's only hitting the x-axis one time, so there is one real solution in this problem. You don't have to know the numbers. You just have to tell me whether or not they would be positive or negative. All right. Now, we'll graph, and specifically we're graphing, this is in standard form. So in standard form, we're going to start off by taking the axis of symmetry. The formula for axis of symmetry is the opposite of b over 2a. The opposite of negative 12 is positive 12, and 2 times negative 2 is negative 4. So the axis of symmetry is negative 3. X equals negative 3. And I'll draw that with a dashed line passing through negative 3. All right. To find the vertex, you plug negative 3 in. So I'll do negative 2 times negative 3 squared minus 12 times negative 3 minus 10. And you can use a calculator, but you just need to know what you're trying to find. And I always encourage you to type or write out what you're typing in. Negative 3 squared minus 12, negative 3 minus 10. 8. So we knew the x-coordinate of the vertex was negative 3. Now we know the y-coordinate is 8. So I'll put that right here. It's on the axis of symmetry. The y-intercept is 0 something. If you plug in 0, those go away, and you get negative 10. So the y-intercept is way down here at negative 10. And then since I'm 3 to the right, I will reflect 1, 2, 3 to the left, and I will draw my parabola like this. We're not focusing so much on the solving right now. I just want you to be able to sketch the parabola, tell me where the vertex is, all that. Okay, we could find those x-intercepts, but that was basically what we did on the last quiz. Let's do another graph. Opposite of b over 2a, the opposite of negative 4 is positive 4. 2 times 1, there's a 1 there, is 2. So the axis of symmetry is x equals 2. Dash line through 2. Plug 2 in. 2 squared minus 4 times 2 plus 4. We can do this without a calculator. 4 minus 8 plus 4. Negative 4 plus 4 is 0. So 2 comma 0. The vertex is on the x-axis. Okay, cool. Y-intercept 0 comma 4. Right here. Your 2 to the left. Reflect it. 2 to the right. Boom. We got it. Okay, looks good. That's standard form. That was your homework last week. You did a bunch of those. Now we got vertex form. So for vertex form, we're mostly just, hey, can you identify that the vertex is at 3, -2? And if you're not sure why, it's because of the form of vertex form. If it's x minus something, it's supposed to be a minus sign. So if they have a minus sign there, that means they plugged in +3. So the vertex is 3, and then this doesn't change, -2. Some people say, like, you always just flip this one and leave the y alone. The axis of symmetry always goes through the vertex, so if the vertex is 3, -2, the axis of symmetry must be 3. 1, 2, 3, right there. 3, -2 is right here. And then the last thing for vertex form, now you could expand it out and convert it, but if you want to just find the y-intercept, you should know that all y-intercepts have an x value of 0. So what I'm going to do is just plug in 0. And you can use your calculator, but I don't need one. -3 squared is 9, and 9 minus 2 is 7. So the y-intercept is at 7, and then I will reflect that. I'm 3 to the left, so I'll go 3 to the right. That puts you right there. I can do better. It's pretty good. Like that. Another vertex form problem. So in this problem, it's +4. Remember, it's x minus something. They must have plugged in a -4 because they wrote it as x plus 4. So they wrote it as x plus 4 because they canceled them out. So the vertex is -4 and then -2. And that means the axis of symmetry is -4. So that's right here. And then again, to find the y-intercept, you just plug in 0. This one might be a little bit more annoying, but probably not too bad. So if you plug in 0, I'm going to say -1/2 times, this is 0 plus 4. 4 times 4. 4 squared is 16. Half of 16 is 8. It's going to be -8 minus 2. So 0, comma, wasn't the other one -10? Oh, okay, never mind. This one's -10. All right, so I got the vertex at -4, -2, and then the y-intercept is -10, and I am 4 to the right, so I'll go 4 to the left, and I got my parabola like this. And if I said, where are the x-intercepts in this problem? There are no x-intercepts. If you try to solve it, you would get complex zeros. Now let's convert between the two forms. We have vertex and we have standard form. To convert into standard form, you need to expand this guy out first. So what I do is I write that out, x minus 3, and now I'm going to ignore the 6, and I'm just going to FOIL this. X squared minus 3x, then distribute the -3, minus 3x, and -3 times -3 is +9. Do anything else with this +4. Combine like terms. X squared. -3 and -3 make -6. Oops. Gotta keep my color scheme going. Now, after I've expanded that, I will finally distribute my 6. 6x squared minus 36x plus 54 plus 4. 6x squared minus 36x plus 58. So, if I said, what's the vertex? You should look at vertex form. The vertex is at +3, +4. Again, you flip this one, so +3, and this stays the same. The y-intercept is right there, 0, 58. Okay, you could plug in 0. 6 times -3 squared plus 4. 9 times 6 is 54. 54 plus 4 is 58. You can get it either way, but if you have the standard form in front of you, it's pretty easy to just look at. One more like that. Remember, focus on the binomial first. Expanding that x minus 4 squared is the most important thing. Leave the -5 alone, and then I'll just expand this. X squared, can we do this in our head? X squared. Minus 4 is minus 8x, and -4 times -4 is +16. So I combine the like terms in my head. Distribute the -5. 5 times 16 is 50, and 30 makes 80. -5x squared plus 40x, -80 plus 5 is -75. So there's standard form. Now if I say where's the vertex, I'm going to look at vertex form. It's 4, 5. Where's the y-intercept? I'm going to look at standard form. 0, -75. Oop, that's kind of blocking. There we go. So that's going into standard form. What if I want to go into vertex form? This is when we complete the square. And when I complete the square, I make that 0 for now, and I move everything that's not an x term to the other side. Negative 17 plus something, x squared minus 10x plus something. And I like to draw the picture, so let me draw a complete the square box for myself here. I'm going to need 2 of them. Okay, so we'll do that. There we go. Let's get rid of this one. Okay, and over here. All right, we'll use this one next problem. Okay. So when I complete the square, I always take half of b. It's always x, and then half of negative 10 is negative 5. So the side of my square is x minus 5, x minus 5. That helps me find the corner. 5 times 5 is 25. So I'm going to add 25 to both sides. On the left side, 25 minus 17 is 8. And on the right side, this is factorable, but you don't need to do any work. It's right here. It's x minus 5 times x minus 5, which we'll just write x minus 5 squared. Last thing, we wanted to say, we want everything on one side in vertex form, so I'll go back, this is 0, but I'll go back to y, and now it's x minus 5 squared minus 8. When you move the 8 to the other side, you get negative 8. So the vertex I can see now is at positive 5, negative 8, and the y-intercept is 0. Oh, wait, no, right here, 17. So you complete the square, but instead of solving, like sometimes we kind of go into autopilot and we solve, we're not solving, we're just going to move the 8 back to the other side, and now it's in vertex form. One more, and this one's a little trickier because you got a 4 out front. So first, I'm going to do minus 68 on both sides, and I'll leave myself a blank. And on the right side, I have this 4. I have to factor that out to complete the square. You have to factor that out. So it's going to be x squared plus 32 divided by 4 is 8, and then I'll put my blank right there. So you move the 68 over, now it's negative. I'm going to get ready to complete the square. And on the right side, I factor out whatever a is. Whatever that a value is has to come out. Now, we're completing the square right here. Half of 8 is 4. So we're going to add 16 to both sides. But you got to be careful, because it's really not 16. It's really 4 times 16. Okay, it's completing this square, and in this square it is 16. But we factored out that 4. So 4 times 16 is 64. So now I have negative 68 plus 64 on the left. That's negative 4. And on the right, I can now factor. That's x plus 4 squared. That's what this is helping me do. Add the 4 to both sides, and we'll just say y equals, add the 4, now it's plus 4. That is the vertex form. So the vertex is at negative 4 because I'm taking the opposite of that, positive 4. And the y-intercept I can see right there is 0, 68. And you can check that by plugging 0 in here. 4 squared is 16. 16 times 4 is 64, and 64 plus 4 is 68. So I feel real good about this. What am I going to get on this quiz? 100%. If you can do this study guide, you can do this quiz. If you've done all your homeworks, if you've done the practice problems, you're going to ace this quiz. Smash that like button and smash that subscribe button.